Okay, so binomial distribution. So let's see. Okay, so first the mean Ex, right? So we know that from the basic formula, Ex means you have to take the X value from the discrete probability distribution, something like this. Take the X, multiply with the probability, then you add up with this X multiplied with the probability, then add up with this X multiplied with the probability, and X multiplied with the probability. Then you will get the mean. This is the basic concept of the mean. Okay, so over here for binomial distribution, we can simplify this process by just taking n multiply with p. N multiply with p. So why? Because they have the same probability. So that's why the process is getting easier. Just take n multiply with probability and you will get the mean. Okay, so this formula is for binomial distribution only, but this formula is for all the discrete probability distribution. No matter they are binomial or not, as long as they are discrete, then you can use this. But this one is for binomial only. Variance. So variance, we have shortcut also. So the formula to find variance under binomial distribution is NPQ. Okay, so the NP has been found from the previous part, 1.25, then multiply with Q. So how you find Q? You see N is 5, right? P is 1 over 4, right? So Q is 1 minus 1 over 4. Then you get 3 over 4. So you know P is probability of success, Q is probability of failure. So to find the probability of failure, you just use 1 minus probability of success, and then you get the variance. To find the standard deviation, you square root the variance. Square root the variance, then you get standard deviation. So this is the value, standard deviation. Okay, now let's see what else they give here. Discrete probability distribution. So remember, this is actually the table. It refers to the table. A table with first row X, second row probability. So we can see how the probability is distributed with different values of X. Okay. And then if you draw out the graph, you will get something like this. You see it's the probability represent the height. So this is 0.1, 0.2, 0.3, 0.4. Okay, so binomial distribution, of course, you can build out the discrete probability distribution table also by using 0, 1, 2, 3 and so on. Depends on the n. If the n is 5, then 0 to 5. And to find the probability, so we can just use this formula, NCR, P to the power of R, and then Q to the power of N minus R. Okay, let's say one example. Okay, so let's say I have a binomial distribution, N equal to 3, P equal to 1 over 4. Okay, so what to do is, let's say I find out the probability first. I know Px equal to R equal to NCR, P to the power of R, Q to the power of N minus R. So once you know this, then basically now we can key in this into the formula, into the calculator. 3CR 1 over 4 power R, 3 over 4 power 3 minus R. So when I key in this formula in my calculator, right, so I just use 3cx times 1 over 4 power x times 3 over 4 power 3 minus x. So I can key in. So let me key in first, then I can get the probability straight away. Okay. So 3cx 1 over 4 power x multiply 3 over 4 to the power of 3 minus x. So depends on what calculator you're using. So to count the x, right, so we can just press alpha close bracket. Okay, so and then the x will come up. So after you key in this whole thing, right, then you press calculate. So when you press calculate, they will ask you the x value, so you just key in from 0 to 3, one by one. So at the same time I build the table. X probability 0, 1, 2, 3. Now I key in 0 in my calculator, so I get 27 over 64. They put in fraction. I key in 1, 27 over 64 again. I key in 2, 9 over 64. Then I key in 3, 1 over 64. Okay, so to find out whether this is correct or not, you just need to add up the probability. If you get 1 at the end, then it is correct. So I check already, we get 1, so this is correct. Now we look at the graph. Probability versus 0, 1, 2, 3. Okay, so it's like this. So this is the binomial distribution. In general, a binomial distribution, right, the graph is either like this, okay, something like this, or like this, or like this. It depends on the value of p. Like this, in general. This is like symmetry. So if the p is small, so it will be like this. Okay, for example, this one, the p is kind of small, smaller than 0.5 is considered small already. So you see it's like this. We call it skew to the right. Skew to the right. So you see right hand side is like very long one. Okay, so if p is big, you see the graph to be like this. Left hand side very long. Okay, so skew to the left. And this one, symmetry. This one, when p is very close to 0.5 or 1 over 2, then the graph is symmetry. So binomial, the graph is like that. Okay, now let's continue. Okay. So basically, you see, if I look at the note here, I understand that we already finished up binomial distribution. We are going to start with something new. So conclusion for binomial. Okay, so first, the formula. What formula do we need to remember? Probability formula. And then mean. Ex equal to NP. Variance x equal to NPQ. Standard deviation equal to square root of NPQ. So these are the 4 formula for binomial distribution. So you just need to remember 4 things. The 4 formula for binomial distribution, and when can we use binomial distribution. So make sure you have n, you have p, you have q. Make sure the probability is the same, and make sure they repeat doing the same experiments for a few times. That is n. Okay, so probability must be the same, and then you can use binomial. So if probability is not same, then you cannot use binomial. Okay, so we finish up binomial already. Now let's continue with continuous probability distribution. So continuous, so of course, in general, I put it in this way first. You see, our probability distribution is subdivided into discrete probability distribution and continuous probability distribution. So we have 2 types, discrete and continuous. For the discrete probability distribution, we have binomial and others. Okay. For continuous probability distribution, we have normal distribution and others. So others that I mean is, if you learn it, then I tell you, like, if you don't learn, then no need to know about that for temporarily. Yeah, so under each of the distribution, so we have the specific special case. Okay, binomial is the special case, normal distribution is the special case under continuous. Okay, so try to recall back. Discrete can only take exact value, normally integer 0, 1, 2, 3. Continuous can take exact value as well as decimal numbers. All the values in the interval is acceptable. So continuous probability distribution. So first we have the PDF. PDF stands for probability density function. Probability density function is represented by using fx. And fx is used to sketch graph. Okay, we use fx to sketch graph. How about discrete? Do we have fx or not? So actually, yes. In discrete, we have fx, which is known as probability function. In discrete, okay. So I just put here as comparison. In discrete, fx is equal to px equal to x, px equal to r, or px equal to x, which is probability function. So for example, this is the probability function. So this is the fx. Okay, so in discrete, that is the fx. Fx is used to find probability. It's used to find probability. In discrete, fx is used to find probability. In continuous, fx is used to sketch out the graph. So different function. Okay, so this one, I put a short note first. The fx here, probability function, is used to find probability. Compared to continuous, the fx is used to sketch graph. Then how to find probability? So I put the information here also. After you sketch graph, probability is area under graph. So you may think of, area under graph. Area under graph, then I have to use integration to find it. You may think of that because integrations that we learned before represent area under the graph. So we may need to use that. Okay, so it depends on the questions. Okay, so now let's see example first. Example 1, fx equal to 0 for any other values, but fx equal to half x for the interval 0 to 2. So you know fx equal to half x is used to sketch the graph. So you have to sketch y equal to half x, which is a straight line from origin. So how we know from origin? You just substitute. You substitute 0 inside, right? Then, for example, I put the working here. Y equal to half x, or fx equal to half x. So when x equal to 0, y equal to 0. Okay, so when x equal to the greatest value in the interval 2, y equal to 1. I substitute into the function, then I get 2 points, 0, 0, 0, 0 is here, which is here, 2, 1, which is here. So I join with a straight line, then I get a graph, half x. So that means when you sketch graph, right, 0 to 2 you sketch half x. Other than that, you sketch 0. 0 means you sketch a horizontal line on the x-axis. So something like this. We sketch a graph like that. And then after that, you see probability is area under the graph. That's why they do integration. They integrate, let's say this is just explanation only. It depends on what probability are we finding. So for example, if you want to find probability from 1 to 2, then you integrate from 1 to 2, fx dx, like that. Okay, so now in this example, they are trying to integrate from the smallest x to the greatest x, which means we are trying to find out the total area under the graph. Of course, it's equal to 1, because total area under the graph is total probability. Total probability is 1. So you integrate from the smallest x to the greatest x, fx dx is equal to 1. Okay, to see whether it's really equal to 1 or not, so let's see. The fx is half x. You integrate half x, it becomes x squared over 4. You know, the power 1 become power 2. Then you divide by 2. 2 and 2 become 4. So you get x squared over 4 after you integrate. So this square bracket should close up. And then you substitute 2 into x. Start with the upper limit first. Substitute 2 into x. You get 2 squared over 4 over 4. Substitute 0 to the x. You get 0. So you minus them, end up with 1. Showing that this is total area. Total area, which is total probability. So that's why equal to 1. So they give another example. If you want to find probability from 0 to 0.7, so you just need to integrate from 0 to 0.7. Okay, so after that, let's say if I continue, you will get something like this. Integrate 0, 0.7, half x dx. And then continue. I know integrate half x is x squared over 4. From the previous result, I know already. 0.7, 0. Then I substitute 0.7 into x. 0.7, I square it, then divide by 4. Then I get 0.1225. I substitute 0 into x, you end up with 0. So at the end, only 0.1225 that remain. So that is the probability. It is area under the graph, and it is also probability. Make sure your answer is smaller than 1. It is positive but smaller than 1. You know, probability cannot be negative. And you know, probability cannot be greater than 1 because it represents the percentage. The percentage of something to happen. 1 is maximum already. 0.1225 is a reasonable value. Okay, so that is how we find the area under the graph and use integration to find. Okay, so of course, if you don't want to use integration, right, we can easily find the area under the graph by using triangle, area of triangle. Let's say, for example, we have a graph, right? So the example 2, probability from 0 to 0.7. I know 0.7 is somewhere here, 0.7, and I can easily find the y. So how to find the y? You know, this function is y equal to half x. So I just substitute 0.7 inside. 1 over 2 times 0.7, 0.35. So I can easily find the y. If I can find the x as well as the y, finding area under the graph is kind of easy. 1 over 2 base times height. So you see, probability of 0 to 0.7. 1 over 2 base times height. Without integration, you see. But of course, this is only for straight line. If the graph is curved, you must use integration. If it's straight line, then you can use shortcut. Just find the area of triangle. You see, we get the same answer with just now when we use integration. Okay, same answer. Okay, now let's see example 3. Probability density function. Fx equal to something in the interval 2 to a value. Can't see this value. Okay, and it's equal to 0 otherwise. Okay, so A. So let's see. If you want to find the probability from 2 to 4, so the idea is this Fx is used to sketch the graph. So we sketch the graph already. Probability is area under the graph. So we have to integrate from 2 to 4. So integrate from 2 to 4. Okay, so just for your information also, if you want to find probability from 2 to 4, where 2 to 4 is included, the working will be the same. It will be the same. No matter 2 and 4 are included or not, the integration is just the same. So end up with it is the same answer. Okay, so that means for continuous, no matter you include the integer or you don't include the integer, it will end up with the same probability. The reason is kind of simple, because you see, let's say, okay, let's say in general the graph is like this. 2 to 4 is here. So the area under the graph is this. So if you include the 2 as well as the 4, so it's just that you can include this line and this line. The area is this big, this size, and the line here is included. This line, this vertical line is also included. But we also need to understand that we are finding area under the graph. No matter the line is included or not, the area is that size. It's the same size. Okay? You don't include the line, the size is that size. It's the shaded area. If you include the line, the size is that size also. The area is that size also. So no different in terms of the size of the shaded area. Okay, so that's why same only. But in discrete it is different, you know. In discrete, you see, like in binomial, if they ask for probability from 2 to 4, you can only take probability of 3. This is discrete. You know, discrete means they only take exact value, integers. We can only take 3. But if you have 2 to 4 included, then the probability is px equal to 2, px equal to 3, px equal to 4. So that's why in discrete, all these are under discrete. In discrete, they are different. In discrete, in general, if you want to find probability from A to B, it is not same with probability of A to B, where A and B inclusive. Not same. But in continuous, in general, probability from A to B is always equal to A to B inclusive. Equal one. So be careful. Discrete, different. Continuous, same. Okay, so now let's continue. B. Px equal to 4, 0. Px equal to 4, right, is area under the vertical lines of 4. A vertical line has no area. Okay, so that's why equal to 0, because no area. A line has no area, so no value. Compared to discrete, right, probability of x equal to 4, we have value. Okay, we have value. So you just substitute the 4 into the probability functions, then you will get the probability. You will have value. But in continuous, when they ask for the probability of one single value, we always have 0 area. 0 area if it's one single value. But in discrete, yes, we have value. In continuous, no value. So in general, it is going to be like this. In discrete, probability of x equal to a value, then we have value. We can easily find it. Depends on the probability function. But in continuous, probability of x equal to a is always equal to 0. So that is another difference. Okay. So we have done everything on this page already. Now let's move on. C. Probability of x less than 4 is equal to probability of x less than or equal to 4. This is the same idea like just now. In continuous, with equal or without equal, same one. Okay, so of course, try to look at the graph to understand it. Let's say, for example, okay, let's say 4 is here. Probability of x less than 4 is this area. Okay, so less than or equal to 4 is the same area, but include this line, include this vertical line. We have to know that vertical line has no area. So no matter you include it or not, the area is still the same size. Okay, so like what we discussed just now, you can integrate, integrate from smallest x, depends on the question, smallest x to 4, fx dx. Okay, so even if you include 4, the way to integrate is still the same. It is still integrate from smallest x to 4. Okay, so that's why I end up with the same area and same probability. This one D, same also. Probability from 2 to 4 is equal to probability from 2 to 4. So you can see here, this one include 2, doesn't include 4. This one doesn't include 2, but include 4. No different one. No matter how you include or not include, they are just the same in continuous. No difference. But in discrete, there is a difference. Okay, there's a difference. This one just now we discussed already. Okay, so you see in discrete, in discrete, there is a difference. If you have px less than 4, then it is px equal to 0 plus px equal to 1 plus px equal to 2 plus px equal to 3 in discrete, as well as binomial. Discrete binomial, they are under the same one. If you have px less than or equal to 4, right, then it's different. It's 0, 1, 2, 3, and 4. So like this, 0, 1, 2, 3, 4. Okay, so we have many values. We have one extra value actually, when you compare with this one. This one 0, 1, 2, 3. This one 0, 1, 2, 3, 4. So they always have difference when we talk about discrete. Okay, when there is no equal and equal, always different. But in continuous, no difference. No different. Even for part D also. So in discrete, I just say that only. You try to imagine. In discrete, this is probability of x equal to 2, probability of x equal to 3, 2 and 3. But in discrete, this one is probability of x equal to 3, probability of x equal to 4. So this is 2, 3, this is 3, 4. Different one. In discrete, they are different. But in continuous, no difference. The area under the graph is the same. Okay, now we look at this. So this is a formula under continuous. Very important formula actually. Okay, so very important formula. Integrate from negative infinity to infinity, fx dx is equal to 1. So that means what? What is negative infinity and infinity? Negative infinity here means smallest x value given by the question. Positive infinity means greatest x value, okay, given by the question. So let's say one example. Let's say they give fx equal to ax 0, otherwise. This one is 2 to 4. Okay, let's say something like this. So if you want to use that formula, right, this formula, so you can use this formula to find the A. You can use it to find the A. the unknown here. So how? You see, integrate from negative infinity to positive infinity equal to 1. So negative infinity is the smallest x. Smallest x is 2. Greatest x is 4. Integrate ax. And the integration is equal to 1. Because this is where you integrate all the area under the graph. So after that, you integrate. Integrate x become x squared over 2. 2 to 4. Substitute with value. Substitute 4 into x. You get 4 squared over 2. 16 over 2, which is 8. 8a. Substitute 2 into x. 2 squared over 2. 2 squared over 2 is 4 over 2, which is 2a. 6a equal to 1. A equal to 1 over 6. So you can get the a. So once you get the a, then fx equal to 0, 1 over 6x, otherwise, and 2 to 4. So like this. So that is how we use the formula. Okay. Sometimes they may give situation like this one. Okay, let's see. Sometimes they may give fx equal to let's say they give 1 over 6x from 2 to 3, kx square from 3 to 5. Okay, from 3 to 5. Let's say that. And 0 for otherwise. So in this case, what is meant by this formula then? Let's take a quick look. What is meant by this formula? If there are two functions with formula, 0 is not included, no? So these are the two functions that I mean. This one and this one. Two functions with formula, but this one is 0. Now how we use this formula? So we have to integrate each of the function from its corresponding interval. The first function integrate 2 to 3, the second function integrate 3 to 5. The third one no need, because integrate 0 is still 0. Okay, so integrate 2 to 3, 1 over 6x plus, integrate, we add up the area, in other words, 3 to 5 kx squared dx equal to 1. So you try to observe something. No matter it include the number or not, the integration is just the same. You see 2 to 3 included. So integrate 2 to 3. 3 is not included, 5 is included. Same only. The integration show no difference. So that is the characteristic of continuous. No matter you include it or not, the integration just looks the same. So now we add up the areas, then equal to 1. Total area equal to 1. That's the idea. Then we integrate 1 over 6 x squared over 2, 2 to 3, okay, x cubed over 3, 3 to 5 equal to 1. So we get something like this, and then we substitute 3 into x, so I get 3 squared, 9. 9 over 6 times 2, 12. 9 over 12. 9 over 12, 3 over 4. Yeah, okay, minus, substitute 2 into x, 2 squared, 4 over 2, 2 over 6. 2 over 6, 1 over 3. Substitute 5 into x, 125k over 3. Substitute 3, 27 over 3, 9k equal to 1. So again, by solving this, we can find out the values of k. So let us just finish this. So I get 7 over 12, 125 over 3 minus 9. I get 98 over 3k. So k equal to 7 over 12 divided by 98 over 3. So I get 1 over 56. So you can see two different examples on how I apply the same formula. Okay, so two important situations. Okay, now let's move on. This one, I just leave it like this. No need to explain already. I already give enough example. Okay, now we look at the mean here. The mean, as we know, EX. The formula to find the EX is different now. We have to integrate from smallest x to greatest x, x fx dx. Okay, so it's different compared to discrete, right? You see, in discrete, EX equal to sum of x times probability of x in discrete. If you still remember the example, we do something like this. We look at the table, the discrete probability distribution table. We take the x multiplied with the probability, then add up the second x multiplied with the second probability, then add up with the third x multiplied with the third probability, and so on. So we do it in that way in order to find the mean. But in continuous, the way to find the mean is different. We have to integrate the fx and multiply with the x. So let's say, for example, okay, if I have this fx, I want to find the mean. So what I do, okay, let's take a look how I find the mean. You want to find the mean, EX, integrate 90 infinity to infinity x fx dx. So how we applied it, integrate 2 to 4, smallest x to greatest x. And then you take the, imagine you take the x, multiply with the fx. That means you take x multiply with 1 over 6x. You will get 1 over 6x squared. 1 over 6x squared. 1 over 6x squared dx. Okay, then I integrate it. X cubed over 3. X cubed over 3. 18. 3 times 6 is 18. 4, 2. So remember, now this is mean. This is not probability already. This is mean. The value of mean can be greater than 1. Not like probability. Probability must be less than 1. But this is mean. Mean can be greater than 1. So you see, if I count it, I can easily get greater than 1 actually. So I have 4 cubed over 18. 4 cubed over 18 minus 2 cubed over 18. Minus 2 cubed over 18. So I get 3.11 as the mean. So we can easily get the mean to be greater than 1. Okay, so which is normal. Make sure your mean is in the interval. If your mean is not in the interval, wrong already for sure. Okay, so mean must be somewhere in between the interval. Okay, so now let's see it again. If I have two fx rules over here, then how to find the mean? Let's take a look. Okay, I found the k already, right? So I just substitute the k back to the function. So I write it again. My fx is now 1 over 6x 2 to 3 1 over 56 x squared 3 to 5 0 or otherwise. Okay, now this is my functions where the information is enough to find mean. Now you see how I find mean. The formula is still the same. Integrate from negative infinity to infinity x fx dx. The same formula. But how to do it if there are two functions? Okay, so we have to integrate 2 to 3. Take x to multiply with the first function. X multiply with this. 1 over 6x squared. Then you plus 3 to 5. And you take x to multiply with this function. 1 over 56 x cubed. Okay, then you integrate. So let's say if you integrate, you get 1 over you get x cubed over 3. 3 times 6, 18. 3, 2. Then integrate x power 3 become x power 4 over 4. 4 times 56. 4 times 56, 224. 224. 3 to 5. Okay, then I substitute 3. 3 cubed over 18. 3 over 2. 2 cubed over 18. 4 over 9. Plus, okay, the second one, put 5 inside. 5 to the power of 4 over 224. I get 625 over 224. Substitute 3 inside. 3 power of 4 over 224. 81 over 224. 3 over 2 minus 4 over 9. 625 over 224. Minus 81 over 224. Okay, so I get 3.48. Okay, so what you need to know is your mean first can be greater than 1. Second must be inside the interval. Our interval is 2 to 5 basically. 2 to 5. So must be somewhere in between. Okay, so that's the mean. Okay, so we have done mean. I hope you understand already. Now variance. Variance formula is integrate from negative infinity to infinity x squared fx dx minus with mean power 2. The mean here is the previous answer. So what you found just now, the mean, you put here, you square it, then you can get the variance. So example, let's see a quick example. So I just show you how to start on it, or else the working it will be too long. Okay, so let's say I use back this example again. I have the mean ready. Now I want to find variance. So based on the formula, I need to integrate from negative infinity to infinity x squared fx dx plus mu power 2. Okay, so our interval is this interval, 2 to 4. The function is 1 over 6x. So you integrate from 2 to 4. You take x squared multiply with the 1 over 6x. X squared multiply with this 1 over 6x cubed dx minus with not plus, wrong already, minus. Minus with mean power 2. That means minus with 3.11 power 2. We found the mean here. This is the mean. The EX is the mean. So you minus with the mean power 2. Then after that, I leave it to you. you know, you have to integrate, then minus with this value. So this one, I assume you understand already. I just do the starting only, because the steps might be too long. Okay, so let's see this also. If you have two functions, how you find the variance? Okay, so we do like this. You want to find the variance? I just show you the starting steps only. You integrate from 2 to 3. You take x squared to multiply with the first function, 1 over 6x cubed. Then you integrate from 3 to 5. Take x squared and multiply with the second function, 1 over 56, x power 4 dx. Then you minus with mean power 2. Minus with 3.48 power 2. Then you keep doing this and you will get the variance. So you have to integrate and substitute the upper limit followed by lower limit. And then you can get the variance. Okay. Now, standard deviation, we square root the variance. You square root the variance, you get standard deviation. So of course you have to find variance first. Then only you square root.